welcome to this session. So my name is Dario Tranchitella, I'm technical advisor at Classics, the company behind Kamaji. And in this video we are going to see how Kamaji it integrates with Ranger. So right now, as you can see here, I already have some terminal control planes and we have Ranger. So keep in mind that we need a functional Ranger and we have to install in the local cluster Kamaji. So how can I do that? Essentially what you have to do is to browse in the apps and look for Kamaji, as you can see here, and I can install that. Once it got installed, I will end up with some resources like the data stores and the terminal control planes. Right now, in the terminal control planes, I already provision some Kubernetes control planes. So what's the benefit of Kamaji? Essentially, Kamaji is running control plane components as regular pods in a management cluster. So as you can see here, we got a Kubernetes vanilla running 125 and we got another instance running 126. Let's see how can I create a new cluster running 127. So I can click on the button create from YAML, and as you can see here I can specify the name. It's going to be Kubernetes 127, and I can add further details. Just for the sake of simplicity, I'm going to say that we need core DNS at add-ons. We need also to specify the core DNS, well, not the core DNS, but rather the connectivity port for the server, and we need also kubeproxy here. Finally, we can add some deployment information like the amount of replicas. Since we're running as pods and we need to ensure high availability, we are going to add 2 replicas, and all these values can be removed because they are not required for our demo. We don't need an ingress, but rather we need to expose our terminal control plane using a load balancer service. We are going to use the default data store, but obviously we need to specify some information about Kubernetes. So we are going to use all the admission controllers. We can remove that. We need to use the systemd cgroup fs driver because we are going to join nodes from AWS, and those are real nodes, and we're adding also the version. So we want to use the 1v1.27.0. And in the network profile, we just need to specify the ports, so 6443. All the data here can be removed. So as you can see here with Kamaji, we are declaring the state of our control plane. And once we click on create, you can see here that in a matter of seconds, once the load balancer solution is providing us an IP, our control plane is will enter in the provisioning state. So what is doing Kamaji? Kamaji is doing the dull stuff on our behalf, so creating the API server certificate, the certificate authority, and all the required components to have a fully compliant CNCF Kubernetes cluster running as pod. And as you can see here, just in a matter of seconds, we got our kubeconfig generated that can be used to interact with this cluster. So what I could do is to use the kubectl get secret command and reading this secret, but keep in mind that Classics also developed a dashboard that will be enabled here and available here as an extension, as a Ranger extension. Right now we developed this dashboard, and as you can see here I got my Kubernetes cluster, and what I can do is to view the kubeconfig and download it to interact with the cluster. It has been downloaded, so what I can do is to export that in my shell downloads kubeconfig, and as you can see here, if I issue kubectl version, I'm running 127, and if I issue kubectl get nodes, I don't see any node because the control plane is managed as a pod, so it means that it's like having a sort of managed Kubernetes service because everything is offloaded to Kamaji and Ranger. Now what we have to do is to ensure that we got our connection with the console, and we need to create some nodes. So I click on Kubernetes 127, and the Classics dashboard right now supports creating some nodes on AWS. So I'll add a pool name, I select the region, the security groups, and also the subnets. for these nodes. I'll pick up a Ubuntu image and a T-Medium EC2 instance type. And I want two nodes with 16 GB of root storage. And now what we have to do is to wait on AWS to get our nodes created. In the meanwhile, what we can do is to try to take a look to the other clusters here. So these have been created in advance and they have been already registered as clusters. So I can browse these Kubernetes clusters because I got some nodes and the Rancher agent has been installed there. Now it's just a matter of seconds to be sure that our nodes are going to be deployed and joining this cluster using kubeadm. In the meanwhile, what we can do is to install, pretty sure, a missing component, that is the CNI. So since I'm already having here my kubeconfig, what I have to do is to install Calico. And in the meanwhile, we can wait here for our nodes joining this new cluster. It took some time, but as you can see here, the nodes are joining and the CNI is going to be deployed here. And in a matter of seconds, we should be able to get our fully compliant CNCF cluster running in a mixed environment, because the control plane is managed by Rancher, but the worker nodes are bring in by the tenant user. So I could use nodes coming from AWS, from Azure, DigitalOcean, or even on-prem, because Kamaji is taking care to automate all the required components to allow the communication from the control plane to remote nodes, even if these nodes, they don't have a public IP. So it opens really huge business opportunities to offer a managed Kubernetes service or to decrease the operational burden. So the nodes are there, and if I issue kubectl get nodes, as you can see here, our nodes are ready. So what we have to do now is to come back on Rancher and to register this new cluster as a regular cluster for Rancher. So I have to import an existing one, a generic, and I can type the name, and it's going to be Kamaji 127. I can create that, and I'll have this kubectl apply command that I need to run against my tenant cluster. So I already copied that, so I just need to apply this one and wait for the Rancher agent to get deployed. In the meanwhile, what we can do is to try to understand how it works, our integration with Rancher and Kamaji. So in the local, as you can see here, we have the default namespace where we got our deployments that are the control planes running as regular pods. So here, as you can see, the control plane is running as regular pods in a deployment. So what I can do is to scale the deployment. So if I need to handle more traffic, what I can do is to click on the tenant control plane definition, edit, and increase the amount of replicas. So I can look for the controller, deployment, replicas, and I can scale up to 3. And my control plane will be updated, and I'll have 3 replicas to handle more load. Keep in mind that this works for the scale out, but also for the scale in. So with Kamaji, I could provision clusters in a matter of seconds and scale them to 0, and I can save resources and turn on them only when I really need them. Also, there are some features that are really interesting, because on setting the kubeconfig, you see here that I got some resources. So I got all the required components to run a control plane. So the certificate authority, the controller manager, kubeconfig, and so on and so forth. So what happens if I delete some secrets, like this one? The secret has been deleted, but if I issue again kubectl get secret, this secret has been recreated. So essentially Kamaji is like having a fleet of site reliability engineers that are doing the required job to upgrade, update, ensure the availability of control planes. Now let's switch back on the cluster management dashboard, and as you can see here, the cluster is waiting for the API to be available. And as promised, it was just a matter of minutes and we got our tenant control plane with real nodes running in a different provider that is self-registered in the Rancher management cluster. And what I can do is to explore this new cluster, and as you can see here, I got my nodes that are worker, and I can browse across all the namespaces and the workloads deployed there. So what's the advantage of Kamaji? Firstly, I can create high density control planes because they're running as pods. I can offer a management service for Kubernetes, and I can take advantage of Rancher and its features about managing the users and the permissions to distribute the access to these clusters. So what I have to do is to download the kubeconfig, and I can access these clusters that could be, from the API perspective, remote, and having a single entry point that is really helpful for auditing and other purposes. So I hope that you enjoyed this video, and if you have any question about the Classics console, or rather the features that we are implementing with Kamaji and Rancher, please drop us a message. We are at the booth at the SUSECon, and I'm looking forward to meeting you. Thanks.